9702 November 2020, paper 2, variant 2. The topic is from the DC circuit. Question number is 6, part A. A network of three resistors of resistance R1, R2, and R3 are shown in figure. So as we could see, the current I is passing through this point and distributing to I1, I2, and I3 through R1, R2, and R3 respectively. And the potential, as these three are in parallel combinations, the potential difference is V is same for all three. So you need to show the combined resistance R of the network is given by 1 over R is equals to the 1 over R1 plus 1 over R2 1 over R3. So this is a straightforward Kirchhoff's first law. It says at a point, at a junction, the current which is flowing into this point will equals to the sum of all current passing out of this point. So the total current I is distributing to I1 plus I2 plus I3. So this is the total current. So the I equals V over R, then V is the total potential difference, R is the total effective resistance, is equals to V over R1 plus V over R2 plus V over R3, because the V is same for all three resistors. So taking V as a common, so 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3, hence proved. So a battery is of electromotive force 8 volt and the internal resistance R small r is connected to three resistors X, Y, and Z as shown in this figure, right? So the I current is passing through this XZ, which is 0.49, and for Y is 0.45 ampere. 16 ohm resistance for Y is given. So that means I, which is coming from this point, it is distributing to this and this, which is 0.49 plus 0.45 ampere. So what is the question? It says part 1, the resistance we okay. So resistance Y has a resistance 16 ohm and the resistance at 0.49 ampere. The current is the resistance Y is 0.45 ampere. Calculate the current in the battery. So total current is 0.49 plus 0.45. So here it's 0.49 and 0.45. This is distributing. So combined it will be 0.94 ampere. The internal resistance R of the battery. So before we check the internal resistance, let's check that the potential difference across Y and across Z and across this terminal is the same. So potential difference across this 16 ohm is 0.45 and resistance 6 ohm. So V equals IR, I 0.45 ampere at 16 ohm, which is equal to 7.2 volt. So the EMF is equals to the internal resistance times current as the potential difference across the resistor, the terminal potential difference. So 8 is the EMF, 0.94 is the total current, R is the effective internal resistance, and the potential difference as we calculated earlier, 7.2 volt. So after solving it, small internal resistance is 0.8 divided by 0.94, 0.85 ohms. The resistance X and Y are made from the wires of the same material and the cross section area. So the cross section area and the material is the same. So we need to calculate the average distance and the average speed of the electron is x of the electron in x is 2.1 into 10 to the power minus 4 meter per second. We need to the same speed, drift speed for of electron in Y. So we know I equals nave, number density, cross-section area, speed, and the electron charge of an electron. Same formula for x and y. So Ix equals NAVXE, Iy is NAVYV. Y, E, and A, E are the same because the question says the number says clearly that the material is the same, so number density is the same, cross section is the same, A is the same, and charge of electron is also the same. So Ix over Iv equals NAVXE NA of Y. So NAE cancel out. Ix over Iy is equal to Vx over Vy 0.49 divided by Y 0.45 2 is equal to 2.1 into 10 minus 4 over Vx. Vx is equal to 1.9 into 10 power minus 4 meter per second. Resistance Z is replaced by the new resistor of the resistor of smaller resistance. State and explain the effect of any terminal potential difference across the battery. So this Z is replaced by another resistance which is smaller in resistance. So that means the effective resistance decreases. If the effective resistance decreases, so the total effective current will also will increase because they are reciprocal, they are indirectly inversely proportional, and when the resistance decreases, potential difference will also decreases. Therefore, the terminal potential difference will also decrease.